Before we get started, I just wanted to share some info about the game we're working on. It's called Humans in a Box. It's about a human who's stuck inside a box. We think it's gonna be hilarious. Head out to humansinabox.com for more detail. Okay, let's get back to where we were. So we had this little runner game. What I want to do is turn it into some kind of platformer game. So there's a few things I want to do first. What I want to do is show all the data of the game. So the position of the hamster, the tree, everything that represents our game, we're gonna store that into some kind of global data. Okay, good. But I want it to refresh while I'm moving, so I want to keep repeating the loop. So you see that now the global data gets updated as soon as I move. It reflects exactly what's happening on the screen. So for example, the hamster, as soon as it jumps, the Y position changes. So it's very useful for debugging. So I guess let's store the score and game over as well. Okay, so now we even have the score and the game over status inside the global data. This is perfect. The next thing I want to do is a little bit of refactoring. So I'm going to be moving some functions out of this big giant chunk of loop. When I move it outside, it doesn't know what hamster is, so I should pass it. Let's see. Here we have game info, hamster, where it used to be, probably somewhere in here. Game info and hamster. Another thing that I would like to do is I don't like to reload the screen when I have a game over. Let's just reset all the data. Always remember to pass everything. Yeah, so now when I press space, yeah, the game restart as before, but except we don't reload the page because that's dorky. What else? So I want to move the function for handling the movement. Move hamster. So this is a little bit of housekeeping. It's gonna make it easier to follow what I'm doing. Okay, so this is essentially working. It's still working. Okay, good. So this is the basic. We did a little bit of refactoring. Let's move to the next steps. Fine tune the movement of the hamster and then the tree. We're just gonna comment out everything. There you go. I'm just gonna have one tree and I'm gonna put it at position 300. That way we can see it. To close 500. Nice. Now I want to control the hamster. When I press a button left, I want the hamster to move left, and when I press right, the hamster has to move right. The hamster has to keep moving after I press the button. So I want to know if a button is pressed or not. When I press keys, so the key is some kind of variable to identify which keys got pressed, and when I release, I have to do something else. So the keys is going to contain with other keys that got pressed. This is not TypeScript. This is JavaScript, okay. And let's make it part of our global data. So now let's see. Okay, see, any key that I pressed, I can see it. Actually, I don't want the key itself, I want the code. See, so when I press space, it jumps. A, D, arrow up, arrow left. I want to jump when I press space. If code equals space. So if I press anything else, it's not gonna jump, only when I press space. Perfect. Now I'm gonna move the hamster depending on the key. I'm gonna have a variable, dx. It's gonna tell me if I move left or right. Hamster dx equals dx times speed. Okay, so dx is gonna be the direction of the hamster, and now we have to move it. Let's see. Perfect. So now if I press left, it goes left. If I press right, it goes right. So I want to be able to change the direction of the hamster. When it goes to the left, it should turn to the left. For that, what I did is I have a separate animation for it. So see, the first three animation is for the hamster moving right, the other ones is for the hamster moving left. So I'm going to be using that. So the animation, so which one was it? 0, 1, 2, 3. Okay, so 3. Okay, I guess we'll store the tree as well. Doesn't really move, but okay. Anim tree 0. So now when I draw the hamster, I'm going to choose the animation. We want to change whether or not it's idle or not idle. State equals run, otherwise idle. State left or right depending on the position of the hamsters. If it's higher than 0, right, otherwise left. It's not exactly correct, but it's fine. We're going to change that later. For now, I just want something that works. Now our animation is going to be an array of integers, and we're going to loop through them. So we iterate through the animation length frame. Run idle left, run idle. Ah, okay, this is a little bit weird the way I set it up. Okay. Now this works. So when I go right, it turns right. When I go left, it turns left. But when I stay idle, it keeps switching to the left. I don't like that. So we had the X. We're gonna have direction. So first it starts as 1. Only if we change the direction, then we set it up. Hamster direction equals dx. Okay, that's good. So the direction is only going to change when I guess when I change the direction, when I move. Hamster direction. Now perfect. Now if I stop, if I go right and I stop, it doesn't suddenly turn to the left. Okay, so we covered keyboard control, we covered animation and direction. Okay, next we're gonna cover collision detection. So the first part of collision detection, I wanna be able to see the collision. We're gonna define something inside the hamster. We're gonna have some collision box. Let's just put some random number at first. And we're gonna draw that tx fill star should be 0.3 maybe. We're gonna the collision. Okay, so collision. Okay, so we want the rectangle first. So the first number is the x offset, then the y offset, then the width, and then the height. And we have to offset that with the x and y of the hamster. And then we can draw our collision like this to draw the whole rectangle. See, now we have a little rectangle that covers our little hamster. And then it's not exactly covering correctly, so now I can change parameters. No, 15. Okay, that's pretty good. The width should be less, so maybe 80, 70, 75, 72. Okay, now it covers well the width of the hamster. Now let's cover the height. So let's go up a little bit, minus 10. No, 10 is actually good. And then maybe 30, that's too little, 40, 35. That's pretty good. I think it covers pretty well. So we have the hamster. The thing that we just did is we draw the collision box. Let's put that into a function. So we took the hamster, we took its collision rectangle, and then we just draw it. We're gonna change that to element. The reason I'm doing that is because I want to do the same thing for the tree. Draw tree, where's draw tree? Yeah. Now the tree needs a collision box. So same thing, okay. So we're gonna adjust that, 40. Let's make it, let's change this first. 50 maybe, 80, C5. So I'm doing this until I completely cover the tree. Okay, perfect. So now I have a box around those elements, regardless of the graphics, that can cover the collision area. Okay, we're gonna take a little break and come back. Yeah. If you have some time, please head to humansinAbox.com and sign up to a mailing list to try our game. Okay, so now we have this game. We have collision boxes around each character. I just want to make sure that when the collision box collide, I can detect that. So when we have one square A, to determine if it's collide, we have to check on one x-axis if they overlap, and on the y-axis if they overlap as well. So let's see, A and then B, A and then B. To detect if they overlap, we're gonna check the edge of each rectangle. For A, this is left and this is right, B, left and right. The formula for that is mainly if the left part of one rectangle is below the right part of the other rectangle, and left part of the other rectangle is below the right part of the other rectangle. So basically L smaller than R, and here also L smaller than R. Then in that case, the line overlaps, and we do the same for Y, and then that's how we determine the rectangles overlap. So we're gonna do that. Rectangle overlap. Okay, collision rect for an element. So actually we want to check if two elements intersect. Okay. When I iterate to each tree, I check the collision between that tree and the hamster. Check collision. So if the tree intersects with the hamster, I'm just going to say that the hamster gliding equals true. Okay, so if I check the hamster coordinates, as soon as it overlaps, it should show colliding equals true. That's correct. When it's colliding, I want to change the color. That way I know that it's colliding. So element colliding. So if it's colliding, maybe I'm going to make it yellow. It's not very visible. Make it red. See? So now when it's colliding is red. I want to make sure that if it's not overlapping, we should make it a regular color. Colliding equals false. Okay, perfect. So you see, as soon as it's colliding, the hamster is showing red. Now what I want to make, when the two elements are colliding, I want it to block. So for example, the hamster is going towards the tree and it keeps moving forward, but it's colliding with the tree, so it's blocked. And same thing, if it's landing on the tree, it should be able to rest on the tree. So for that, whenever I do the collision, I need to calculate sort of the push. Okay, so we know that they intersect. Now I want to get the push value. So it's the second element pushing the first element. So right 2 minus left 2. Oh, what is the formula for this? Hold on. So basically what we want to do is calculate this value right here. A needs to get pushed back by a certain amount, or it needs to get pushed up by a certain amount. So this is what we want to calculate. The minimum amount of push so that A gets out of the way of B. Left push, basically. Yeah, so the minimum between all of this. And let's return that. So that said, I want to make sure that they intersect, so check intersection. Okay. Push element intersect. So if there's a push, then we know that it's colliding. Let me just make sure that this still works. Okay. Now we're gonna use the push to push the hamster. So if have apps push. So remember, we want the smallest push out of the two. Hamster y plus equals. So now y is smaller than we're gonna do the y push. Otherwise, we're gonna do the x push. So as soon as it collides, it's gonna push it back, and hopefully that should help. Oh, that didn't exactly do what I want. Okay, so if there's an x push, okay, something wrong here. Oh, let's try to figure this out. Man, this is complicated. Okay, so the left push actually needs to be negative, and the right push needs to be positive. Okay, wait, so no, the left 1 minus. So top push needs to be negative. That should work, hopefully. Okay, good. So I cannot move further. Let's see what happens if I land on top. Yeah, exactly what I wanted. When I land on top, it doesn't go further. Oh, something wrong here. Okay. The right push is not correct. Maybe I need to invert this. And by the same logic, this should be inverted. No. Okay, so one is positive and one is negative, so checking the minimum, it is not gonna help. So push is gonna work. Okay, push correctly. Okay, this is perfect. Now another thing that we want when we're on the top, we should be able to jump, right? Right now, the condition for jumping is that it hits the ground. So what we can say is that when it lands on the top, then it's sort of like hits the ground. This is where it hits the ground. Hamster dy equals 0. So the push needs to be negative. If push y push, then hamster grounded. It's big, okay, hamster y is bigger than the ground. Goes true. And as soon as the hamster jumps, it's no longer grounded. Let me see if that was correct. Grounded, true. Okay, correct. Grounded, true. Okay, good. So now the condition for jumping is that the hamster must be grounded. Yep, there you go. Here it doesn't work, so it's not grounded. I guess as soon as, if it is 0, then it's grounded. Okay. Good. Now we can add a few more trees. Let's have a tree at 600. Another one maybe up in the air. So okay, so here I jump on the tree, good, and I can jump on the other tree. Excellent. So this is working as expected. Okay, so now we have somehow a platform game. We have some blocks on which we can jump. What I like to do next is to have the scene follow the hamster. Move camera to hamster. So we're gonna have some kind of shift value. So all the elements in the scene are gonna be affected by this shift value. We have to add shift value. When we draw the hamster, we have to add shift value. So I need to pass shift into the draw methods. So draw hamster, pass shift, draw tree, pass shift. And to make sure that it works, let's shift by 100. Let's see what happened. So everything is shifted to the right. I see also the collision needs to be shifted. Perfect. Okay, so if I shift by 100, everything is shifted by 100. If I shift by 200, okay, 100. Yep. Let's go back to 0. Now I want to continuously move the camera towards the hamster. So let's see if I first set to camera to hamster XY, that's not correct. I want the hamster plus 300 maybe. Yeah, so now it's on the ground. And then move towards the middle a little bit, that hamster, so maybe 200. Okay. Now it always follows the hamster. And another nice thing I like to do is make it a little bit more smooth. So now we're moving kind of smoothly the camera towards the hamster, and it makes for a much more pleasant experience. Now I shouldn't be shifting vertically. Let's just skip this part. Okay, so we're just gonna shift left and right. I think this is fine. Actually, if it jumps too high, I want to be able to shift towards it, so I might as well keep it. And we're gonna fix the ground. Shift Y plus minus. Hold on a second. What am I doing? Okay, so why is it not plus? Oh, it is correct. It's just that like I have a lapse of I have a big area where there's no sky, so I need to make sure that it's filled completely. See, there you go. So there you have it. We have our little platformer. We can leave it at that for now. I'll see you next time for the rest. Ciao.